not some elaborate scheme to get to whittle down the available time, because I guarantee that I will use all of the hour and 25 minutes that have been allotted to me. So I really appreciate the opportunity to speak to you all. We're going to jump into kind of some of the learnings on better software delivery principles through a Panini. For those of you that are just new to the scene here, Panini, after a while, we stopped saying pandemic and started using Panini because it just sounded better and kind of took our minds off what we were doing. So when you see Panini here, really, it's not a talk about a good sandwich, though. Maybe that should be a lightning talk. But anyways, moving on. So software delivery has never been more critical to the success of business in every industry out there. It's also never been more complex. So expectations for delivering high quality software incredibly fast have skyrocketed. Yesterday's most exceptional product experiences that back then were great now are just kind of expected to be beautiful. They're normal. They're kind of meant to be kind of intuitive, powerful, and affordable now. And when it used to be this exceptional thing. And when you look at the landscape of tools and platforms and architectures, that's constantly evolving. And with this rapid pace of change and the growing challenges and of the complexity, how can engineering teams not only succeed, but beat out the competition? I get a headache just kind of looking at the CNCF landscape here of everything and, needing to get out the microscope. And it's not just my old eyes. It's definitely how many are on here. But anyways, so, when we think about surveys and we think about, trying to describe the work we do, we tend to kind of fall into the trap that John Allspaw once tweeted of, work is imagined versus work is done. Or as, we're calling it, we tend to kind of call it is performance described versus performance derived. It's kind of this idea of, you want to describe the way that you do things and, let someone else know, maybe a family member, about how that is. But then when you actually get down and look at actually how you're doing things during a day, that's where we start to see kind of the actual behaviors that are being performed. And so, given that our platform at Circle CI is used to perform many of those activities, which tend to be associated with high-performing teams, it allows us to kind of get a better understanding of how that actual engineering work is getting pushed through the pipeline. Did the developers actually push the code as often as they claimed today and versus last week and maybe last year? And then how long are their workflows actually taking? So as PJ said, my name is Jeremy Meiss. I'm the director of DevRel and Community at Circle CI, and just glad to be here. Yes, I do have blue hair. It's a little darker now, but that's how you find me. That's kind of the trademark. So anyways, and before I get too far into what this kind of looks like, some of you may be familiar of the state of DevOps reports. These are highly valuable. They've really kind of helped to shape and drive the industry into a lot of the important practices and behavior shifts that we've seen. Dr. Nicole Forsgren and her team did just an amazing job kind of putting together the framework for this that eventually the book Accelerate kind of came out of this as well, which I highly recommend you grab that. And, has really been instrumental to where we see kind of DevOps and how teams perform. The big difference between the report that we have that we've been creating each year now, we're 3 years, so that would be each year of the last 3, and these other reports is that, the industry reports, they're largely based on survey data and can potentially kind of be biased on the way that our memories are, that we kind of tend to remember things sometimes better than they actually were. And so, the State of DevOps reports, DORA reports did a really good job of trying to remove a lot of that, but there is still an element of that. And so when we look at kind of the data, we have massive amounts of unique data on how technology delivery teams are behaving, how they're actually doing work. And so we started this in 2018. We published our first report. And then in 2020, something happened. I think there was, the whole world kind of changed. And so we looked at that report and we really wanted to kind of see how developers were working and ran that one in August, September of 2020 and kind of compared the data. And then, now in 2022, we decided to kind of pivot and try and get a larger data set. So the data set for this kind of encompasses almost 2 years of data, which kind of started kind of early, just before the pandemic. So we're saying that would be like December of 2019. And then following that data through until August, September of 2022. So that report is encompassing, over 257 million data points, and over more than 44,000 organizations, 290,000 projects. And we don't believe in kind of a one size fits all metric for how you do software delivery, because every team's different. You're not unless you happen to be from Google, you're not from Google. There's the way that they perform, or the Netflixes, or the the Microsofts, or any of these others that kind of tend to be listed up as a high performing organization. Hopefully, you're not them. And so it's important to kind of understand the patterns that we've seen, and then also kind of the data points from top delivery teams, and then kind of put those together and kind of get some valuable benchmarks that you can use as your goals for your teams. Now, one of the big things that we offer here is, kind of a set of baselines for. There's some metrics that kind of tend to be related to continuous integration that we think of are most important for developer teams. And as far as measuring velocity and engineering efficiency on those teams, the four the four classic metrics would be these of deployment frequency, lead time to change failure rate, and recovery from failure time. And so as we take and look at kind of the data that we have presented, and look at what it means for high performing CI, these are the benchmarks that we've identified. So throughput, that's going to be the average number of workflows that are run per day. The duration of those workflows, how long it takes, the average time to run, the mean time to recovery, and then how long it takes, average time between failure and their next success, and then success rate. So that's just the number of successful runs divided by the total number of runs over a period of time. And now you have all math degrees and can go out and do this all for your teams, right? Build all the metrics. But yeah, these benchmarks here are just some suggested ones that we've seen as we look at the data and what it means to be high performing. So it's important to have a high performing team, much like these here, who I'm assuming are product managers. That or project manager. They're Scrum. I think they're Scrum masters. And so as we've been publishing this research for 3 years, we're kind of pleased to see that more and more teams than ever are hitting these benchmarks. It means that more teams have identified that delivering software successfully at a high velocity is a competitive differentiator for their product, and have prioritized the key components to hit this goal. So by kind of hitting these benchmarks that we have, those high performing teams are getting maximum value from their software delivery pipelines, kind of like getting the maximum value for the rope that is being holding all of these, I guess we identified Scrum Masters up in the air. So looking at data, let's kind of just jump into all this here. Throughput. So throughput is the average number of workflows that are run per day. So a workflow gets triggered when a developer makes an update to the code base in a shared repo, and then a push to your version control system. So whether that's GitHub, GitLab, whatever, which then triggers a CI pipeline that runs the workflow. So there's that kind of process. Large commits tend to be pushed less often. So a lower throughput may indicate that your commits are quite large. And so when you then think about kind of what the size of your commits, you want changes to your code base to be small enough to debug quickly and easily, but large enough to reflect like a meaningful update to your project. So if your goal is to increase your throughput, consider make small commits more often. Doesn't mean you go and you modify a comma here and there in your README file and hey, there's now more commits. We're talking about meaningful change. So throughput is going to vary very greatly depending on the needs of your business. So it's and it's also going to be dependent on like the duration of those builds and the mean time to resolve if there's an issue. So for example, if your pipeline takes 8 hours to run, which would be the duration, you can only commit 3 workflows per 24-hour period. So that would be the throughput. And that's assuming there's no issue within that pipeline or within those builds. So looking at throughput, the mean sits at just under about two times per day. And so, when we think here, that's a couple times a day. That's not bad. But the 95th percentile that's including workflows that were run over 35 times per day, or about once every 45 minutes through that 24-hour period. Your software delivery cadence, it really needs to be dependent on the software your team is building and on your business needs. And I stress the your, because your business and what you're building is different from someone else. So making changes to your product and your project with an automated kind of testing workflow means your organization is no longer blocked by waiting for manual quality assurance checks. That's why automation is so important to workflows and to getting high quality software and delivered to your customers. So, with that fully automated delivery pipeline, it's up to you how frequently and when updates are delivered to your end users. Now, many of the percentiles, we saw a slight dip as the pandemic was hitting, and then the maximum was reached in April of 2020. So this kind of real quick turnaround. And this does make sense in the face of, all the global uncertainty we had in March, April of 2020. We saw a lot of companies were taking their engineering teams, shoring up their business, as quickly as possible, making sure that, that's automating as much as possible. Entire workforce is now at home, so you have a different way of how you're working together, resolving bug tickets, issues. All of those things are being done to really lean on the stability of the platform. So the throughput is gonna kind of go up and kind of have some a dip, but then start to hit that maximum. And if you think about, again, April 2020, that was kind of primary lockdown mode for much of the world. And so we saw a whole lot more code going into the system. We saw also a lot more activity happening on the weekends than had previously been done, along with more hours in a day where these kind of continuous integration activities were taking place per project, which is roughly 14 hours, where it had been 11 or 12. And so that can, definitely be reflected that change of 2 hours is 2 to 3 hours is reflected in no more commuting times. People were not sitting in traffic. So being able to see this data really kind of helps us understand that most projects just are not really deploying dozens of times per day. Some aren't even validating their software dozens of times per day. And so while it's not untrue to say that a description of a high performing team is one that deploys a lot of projects, it just means it may be one project that's really moving that fast. And then there's a whole other kind of subset of projects that, really aren't moving that fast. Maybe they're not the primary thing. Because instead of kind of looking at the total sample of everything that's happening in the engineering department, because really the particular number of deploys per day is not the goal, but continuous validation of your code base via your pipeline is. So when we think about duration, that's the length of time it takes for a workflow to run. So it is one of the most important metrics because creating that fast feedback cycle that includes throughput and the mean time to recovery hinges on that duration. So ultimate goal of CI is really to get fast feedback back to your developers, and so a failed build signal has to get to them as quickly as possible. You can't fix what you're not aware of. So in order to fix it, developers also need that information from the failed builds, which requires that they're getting the right info from the rigorous tests you're running. So all these things are kind of fitting in together. And so when we look at the data from December 2019, which was the earliest time on the report, through September 2021, durations increased on an average for all teams on the platform over that time. And so, this does kind of, again, make sense because more teams are trying to mature their applications and increase their DevOps maturity with the platform. And so they're including more rigorous testing and they're increasing the use of third-party tools to do so it can take a little bit longer. But that also results in, not only workflows taking longer to complete, but it is one of the key things we noticed that throughout the pandemic was, the duration ramping up that started across all the percentiles, it stayed pretty consistent in the trending from there on. They understood that, increasing the duration was important so that they could hit and make sure all the testing was in place so that they were getting that good feedback cycle. The median really kind of puts us at around the 4-minute mark. So as a developer, if you're able to get good quality feedback in 4 minutes from when you started your build, that can be a game changer. And then the 95th percentile is at roughly 34 minutes. And for a lot of companies, depending on what's being built, what are the different testing scenarios, the languages, all of that stuff that's in place, that 34-minute mark is probably a good place to be. We did see the mean fall kind of, heading into the pandemic, and then it kind of just stayed steady with the 50th percentile and above kind of increasing year over year. And that kind of fits with looking at the pandemic and such. Another thing we did see is that duration on default branches was faster at every percentile over non-default branches. So that's telling us that developers are not as concerned when they're working on the feature branches. Is that that can take a little bit longer as they're trying to work on getting to quality code, and then the mainline branch, the test engineering comes in and making sure that everything is quality, so that when it comes into the main build, the mainline branch, it's going as fast as possible. Duration's fast there. All right, so when we look at mean time to recovery, let's say this is the most important metric on the list. The ability of your team to recover as quickly as possible when an update fails, time and time again, is going to be that ultimate goal of agile development teams. The more robust testing, the output that you get that helps there, the faster it is to resolve issues and fix those errors that get introduced into your code base. So, because MTTR, really improves with comprehensive test coverage, avoiding those issues, this metric can be used as really kind of that proxy for how well tested your application is. Although it is, really important to note that error messaging does play a very vital role, and you need to make sure you're calling out your errors very specifically so you could fix those issues. The shortest, though, time that your MTTR can be is equal to your duration, directly correlated to your duration. I figured out that's what that little symbol means. So, for example, if a workflow run resulted in a failed state and a developer immediately knew the solution, immediately made a change, and then immediately pushed it to their shared repository, a lot of use of the word immediately there, the full duration of a successful workflow run would have to complete before the project can return to a green state. So having a healthy build is going to be extremely important here. Brandon Byers at ThoughtWorks kind of told us about the importance of build health and how important it is to ensure steady delivery cadence. He talked about the most robust and certainly the fastest solution to a broken build is simply to revert the offending commit. And you can't know whether a new build works or not unless you're starting from a known good position. So it's hard to imagine a commit more likely to fix a broken build than simply reverting the one that broke it to begin with. Helps you get back to that green so the customers aren't affected, and helps you identify and troubleshoot a whole lot quicker, keeping your MTTR lower as you're trying, getting down there. So when we look at the data, kind of the 5th percentile here, about 2 minutes. That's really low there on the graph. It's sitting in a failed state. A lot of times in those scenarios, we kind of see is that's kind of multiple contributions are kind of running in parallel. So one developer, I push a bad commit. PJ notices that, oh yeah, I know what Jeremy did wrong there, pushes the good commit. So the bad commit fails really quickly. And then that good commit that's coming right along, behind it succeeds right afterwards. So that can be that kind of short 2-minute time frame. It also could be the same developer. I know I've pushed something, realized quickly what I broke. I pushed the fix. So there's kind of that, which fits in that 5th percentile. But around the 50th, we start to see it be a lot longer. You're seeing about an hour until it's recovered properly, which, when we think about over time, that is a kind of an improvement over, of about 3 minutes of what we'd seen before. And then we start to see things as we look at this data, like that are probably getting more attributed to some codes getting pushed. You go home, come back the next day. So that's that, long times. The mean being right about that 14.85 hours, which really kind of illustrates this idea of like, that's the time from the end of a workday to the start of the next. And when we look at the 90th and 95th percentile, that's where it really kind of shows that like somebody's just going home, and maybe the whole weekend. We're seeing improvements over the most part, but kind of this whole going home bit is really kind of interesting because it does kind of tend to butt up against the classic philosophy of you don't go home if the build's red. But if we're be a little pragmatic here, when you're analyzing the build, like, is it the most important? This could be a feature branch that it's not. If it breaks, it's not holding the customers up. They're still able to work. It's just a feature branch, so it's not as important. Maybe it's a test build, whatever that. So those are important pieces to kind of think about here. And when we've looked at this kind of almost 2 years of data, we've kind of observed the MTTR is impacted most by the end of the holiday, end of year holidays. So, this indicates kind of this annual cycle in the market. Predictable rhythm of the seasons is creating more powerful impact on engineering productivity than maybe a global phenomenon kind of did, like a pandemic. MTTR really increased across the board for the end of year holidays, like I said, and it put a lot of small developer teams at a particular disadvantage. So you see these large fluctuations, and it's fluctuations across the board. There isn't just one, percentile. It's all of them. And so this disadvantage is due in large part to reductions of staff, while organizations are hopefully accommodating a healthy work-life balance. We see a lot of companies that decide to code freeze during this time so that they don't have to deal with some of this. And with recovery times also, we've kind of seen it follows the same kind of path. Is that kind of overall, they're kind of declining. We see a big year-over-year drop in that 95th percentile in where it starts, where it finishes. Big drop in May, and it kind of takes itself back up. So feedback cycle here is really at the heart of CI in the rapid app development. And everyone wants to see a decrease, but we see signals like we have here that kind of come from the ability to bring everyone together, focus back on the core business, and shore all the stuff up so that, the uncertainty of, for instance, COVID, the early times there kind of helped to get that signal clearly into developers so they can fix and push code. All right, so finally here on success rate. Success rate is the number of passing runs divided by the total of runs over a period of time. So we're looking at how often does your pipeline complete with a green status. So a pipeline can complete with red, green, or error. So an error just means like something incomplete, like couldn't be done. There was, couldn't finish that step. Maybe it wasn't an error, it just couldn't finish it. The success rate for any given project is not itself like particularly interesting without knowing the development patterns that define your team's use of a version control system. So, these patterns or like Git flow models really kind of organize the work that teams perform on a project onto branches off of the main branch where the production code is hosted. So this is meaning like topic or feature branch development of a project is likely going to have a lower success rate because that's reflecting increased innovation and experimentation. While the main branch itself that holds the production code likely will have, hopefully, a very high success rate that's reflecting the stability of the production code. So since we're really only concerned with success rate here on the default branches, we're looking at it's been sitting at pretty consistently around 75% throughout. We're rising a little bit, but predominantly right around 75%. So when we look at that, all of that, there's in some of the background data, there was always some things that were always green, some things were always red. And so when we looked at that in the between the default and production branches, default and feature branches, excuse me, we saw kind of this typical red to green type of cycle. As we saw, people were testing out new features, innovating. So, it's important here to understand. I want to pause for a second. Is that like no one expects or should expect that every commit be perfect every single time on your feature and innovation type of branches. A healthy, innovative engineering team tends to have somewhat of a high degree of failure, and that's okay. So we don't want to track the success rate there because that's where work's getting done, new things, and you don't know if that's going to work or not. So that's an important piece here. And so overall, we kind of noticed that there was a difference in success rate, like I said, between the different branches. Default branches at the 50th, well, it's not reflected here, was 80% and 100% for, like the 75th percentile and above on the default branches, which is good. So what this tells us is that when we look at, a lot of the innovation that's happening on feature branches, and that had about a 58% success rate. Okay, so kind of closing out here before we jump into some fast round of some quick data. This is kind of what it looks like between the three reports and how things are trending. We're seeing that duration is gone down a little bit, which is good. Kind of is underneath that 5 to 10 minutes. Still, mean time to resolve is still over that less than 60-minute mark. It's actually bumped up this year. Success rate continues to go up. It's less than what we would say is 90%, but it's still going up. And throughput is it really is as often as your business requires it. Some of the extra insights, as we've kind of looked at over the last couple of years, don't deploy on Friday is not a thing. You look at Twitter, and every once in a while somebody will say, "Oh, you don't want to deploy on Friday." It doesn't matter. It's not a thing. Because the reality is that, if you're pushing and you've set all the tests and your confidence in your code because of testing and because of, your get flow models where it's production, default features, and then into default, you have the confidence. Deploy whenever you want to, as long as you have the confidence to do so. And so we didn't really see much of a difference between the different throughputs. Looking at different language shifts over the last few years, we're seeing some interesting things. TypeScript jumping up there, JavaScript, Ruby, Python, those top four not changing. PHP is on a downward trend. Go hopping up there into the top 5 over the last couple years. Some other interesting ones. Rust is starting to kind of make a little bit of a run. Just a good, interesting variety there. When we look at the duration, best duration languages, you understand like shell scripts and they're going to run and exit without probably a lot of robust testing because they just run. And so they should just run pretty quickly. What's interesting is when we see Go, it's under number 19, it's showing up favorably amongst mostly scripting languages and not compiled. Again, on the mean time to resolve, Go shows up here favorably as a compiled language up here with, what's primarily, they're not compiled languages. And then high success rate. Again, you see a lot more text-based high up there with don't have a lot of huge, robust steps and probably doing a lot more artifacts and output. Go again is high up there on the success rate. So really interesting for Go. Hack itself sells itself as like a language that fast development, high throughput. So we're seeing, Hack on our project using Hack on our platform is showing up at the top. Apex, which is Salesforce, is interesting. It's been growing there too. Looking at just how different verticals within industry, how they perform across those. is an interesting stat. And I'll have these slides that you can, I'll tweet them out, and everybody can check them out later. And then, when we think about the DORA report, back to the state of DevOps reports, they've identified kind of what it looks like to be a elite performing team, that elite performer category. And so our consistently in the report, what we've been identifying as what you should have that benchmark fits right in there. So that's just an important stat to understand, is that these two reports work really well together. Validates what we're seeing. So if you're looking for where we sit with going out and seeing both reports from the 2020 and the full 2022, I will share those out as well on Twitter, but circle.ci/SSD 2020 or SSD/2022. You can download the report. Don't have to pay for it. Don't have to give us your email. Just download the report. And that's that. Thank you very much. I appreciate the opportunity. You can follow me on all of the Twitters on generally Jerdog of some sort, or Twitter, I am Jerdog. And thank you very much.